Okay, welcome back. So we're going to use this Halloween bucket again to talk about how we know that the Earth revolves. So what I'm going to do is I'm going to use this golf ball for the Earth. Now we're putting it on this path. You can kind of still see it. We used to have a picnic table here, and my two dogs would chase each other so much that they dug a path. Like you can see it in Google Earth when they were young. You can see like a dirt path because they destroyed the lawn here so badly. So I'm going to use that as the orbit, this golf ball as the planet, that is the sun. And what I want to think about is, I'll put the Earth right there. What we want to think about here is, if this is the Earth and there's the sun, I'll zoom into the Earth. This half of the Earth over here is experiencing daytime. They're facing the sun. Now I know that it's going to spin throughout the course of a day. We're not worried about that. We're trying to prove Earth's revolution. So if the Earth is here, bright side's facing the sun, the dark side then, what we call nighttime, is facing over here, right? I use that rope over there. We're going to say that they are looking at the snake constellation. Does it kind of look like a snake? Maybe? All right, so at night, that's the stars. Those are the stars that they see. That's the constellation that they see, because that is the side of the Earth facing the dark. Now, there's going to be some stars up above the Earth that they can see too, like Polaris and the Big Dipper, those ones that you guys probably know. Everybody knows the Big Dipper, right? But here's what I want to think about. Let's go 6 months later, which means in this situation, there's the sun. I'm going to revolve for 6 months over to here. Now, this half of the Earth is facing the sun, so that's daytime. And again, yes, the Earth will be spinning and giving us day and night. We're not worried about that now. We're still worried about revolution. Here's the question. Can you still see it over there? You see the snake constellation? The problem with seeing the snake constellation right now is that we'd have to look through the sun to see it. In other words, it's only exposed to the Earth during the day, in which case you're not seeing any constellations. Like if I point to the sky up here, there's some constellations back there. I can't see them because it's daytime. The sun's come up, it's turned the atmosphere bright. We'll talk about why that is later in our science. And I can't see those stars that are back there. I know they're there. In fact, I know Polaris is right about there. I know the Big Dipper is right about there. But you can't see them. So some people got to thinking like, geez, if, let's make up a season for this. Let's say this is winter. If in winter, I can't see that constellation that I'm pretty sure I saw in summer, something's fishy. And maybe at nighttime from here, looking from the sun over the Earth, so what do they see at nighttime? They see the Hammer constellation. I'm really having to dig here coming up with stuff at home. But we'll say that there's the Hammer constellation right there. So the dark half of the Earth is facing the Hammer constellation. They would see that. So what people got to noticing is like, hey, in different seasons, I see different constellations. Let's pick up and revolve again just to prove the same point. Back to 6 months, back to where we started. Where now, daytime facing the sun, nighttime we can see the snake constellation. But what are my chances now during the daytime of being able to go way over there and see that Hammer constellation? It's not going to happen. You can't look through the sun. You can't see constellations during the day. Now, this goes all the way around this path. There's different constellations you can see through different seasons. I think the one that always sticks in my mind, the easiest to see, is Orion. Being fall, Orion should be back there in the summer. Sorry, cars coming through. Rare event in these parts. Orion should be back there if you look in the fall, but you're not going to see it in the opposite season, right? You're not going to see it in spring in those times. So this pattern of, we can always see the Polaris, we can always see the ones that are above the planet, but we see different ones behind the planets, has given us an idea that we must be revolving. We must be at a different place in our solar system each month, really, each season. So again, all the geometry of this can be a little bit confusing, but what do we really have to get to is just that like boom boom thing, just like before. So if we remember what we did over here at the swing sap, that was to show us that Earth rotates. We have Foucault's pendulum. Now, to show us that Earth revolves in an orbit we have the idea of seasonal constellations. So that, again, sticking to the very basics, that's going to get you your points when it comes to regions questions, which you guys will start to see. I'm thinking probably next week, maybe late this week, but they'll count on marking period too, so we can wrap up marking period 1 this week. All right, I got one more outdoor experiment for you. The sun should be a little bit higher, but I gotta go inside. So thanks for sticking with me. We'll catch you guys soon. Welcome to Nerd Science.